Hello, STEM Chemistry. This is Ms. Ruark. This is Vodcast 3.3, and we're going to finish up some of this mole stuff. All right, so we're going to talk about percent composition, empirical and molecular formulas. So the percent composition is just telling us the relative amounts of each element in a compound, and it's going to be expressed as a percent. We also call this percent by mass. And remember, percent means part over whole. So if I asked you to find the percent of girls in the classroom, we would take, number of girls, and we put that over the total number of students in the class, right? And then we would multiply it by 100, and it would give us the percentage of girls. Okay, so let's do an example. Let's say that we have 8.2 grams of magnesium reacting completely with 5.40 grams of oxygen to form a compound. Oh my goodness. Okay, we want to know what is the percent composition of each element in this compound. So we have 8.2 grams of magnesium. We have 5.40 grams of oxygen. What's the total mass of this compound? Well, the total mass is 8.2 plus 5.4, which gives us 13.6 grams for this entire thing. We're just going to put MgO because, well, it's a complete and total thing, right? All right, so what's the percent composition for each element? Well, 8.2 for magnesium over 13.6 times it by 100. And then 5.40 over 13.6, and we times it by 100. Okay, so 8.2 divided by 13.6 times 100, and that would give us 60.29% magnesium. And then you could do this math here, or you could just say 100 minus 60.29 gives us 39.71% oxygen. And you can do that because there's only 2 in there. All right, if all you're given in the formula is the formula or name of a compound, then you must use the molar mass from the periodic table. So here it says calculate the percent composition of propane. So in propane we have carbons and hydrogens. We have 3 carbons and we have 8 hydrogens. Well, each carbon has a mass of 12.01 and each oxygen has a mass of 1.01. That gives us 36.03 up top and 8.08 at the bottom. Okay, so that's 1, that's carry the 1, that would be 14, carry the 1, 44.11 grams. All right, well, to figure out the percentage of, and you got to keep going, we're not done. To find the percentage of carbon, we would take the part of carbon, which would be 36.03, over the whole, which would be 44.11, and times it by 100. So that would be divided by 44.11 times 100. That would give us 81.68% carbon. And then to find your percentage of hydrogen, you would subtract 100 minus 81.68, which gives us 18. Oops, not hydrogen. 18.32% hydrogen. Now you could solve it all the way through if you wanted to, but I'd rather just do it quicker. Okay, percent composition can also be used as a conversion to solve for mass. So here it says to calculate the mass of carbon in 82.0 grams of propane. Propane, that was cute. Propane. All right, so we have 82.0 grams of propane, which is C3H8. And they wanted to know what's the mass of carbon. So we're looking for grams of carbon. All right, well, if we have 82.0 grams of propane, and we know, let's go backwards, that in propane, 81.68% of it is carbon. 81.68% of this substance is carbon. All right, well, we could just assume that if this was 100 grams of C3H8, we would have 81.68 grams of carbon in 100 grams of propane. So we can use this as our conversion factor, and we would say that we have 82.0 grams of propane, C3H8, multiply it by a fraction. We want to get rid of grams of propane, so we put grams of propane here on the bottom. And we want to know grams of carbon, so we put grams of carbon on top. Well, how many grams of carbon are there in so many grams of propane? Well, there's 81.68 grams of carbon in 100 grams of propane. Grams of propane cancel, we're left with grams of carbon. and it would be 67.1608 grams of carbon. And we need 3 significant figures, so 67.2 grams of carbon. Okay, now we're going to talk about empirical formulas and molecular formulas. And in order to do that, we need to look at 2 different compounds. One of them is sodium chloride, which is an ionic compound. That would be here. And this one is hydrogen peroxide, which is a covalent compound. Okay, so the main difference here that you'll see is that in sodium chloride, it's a 1-to-1 ratio of sodium and chlorine atoms. Here would be your sodium atoms and your chlorine atoms. Okay, here it's a 2-to-2, which would be a 1-to-1 ratio of hydrogens to oxygens. So here would be your oxygens and here are your hydrogens. But look here, this has a total of 4 atoms and so does this one. This one does not have a total of just 2. It has a network of them. And this is why we would call these formula units. And we show the simplest ratio because we don't want to say, I mean, this could be a small sample of this crystal, of the sodium chloride crystal. So we use formula units, which would be the simplest form. And the reason I'm showing you this is because you're going to need to know that when we do empirical molecular formulas. Right? So, well, first off, what's an empirical formula? An empirical formula is the simplest. It's the simplest formula. And it's always going to be for ionic. We never simplify covalent. Never simplify covalent. We always simplify the ionic. So if we're looking for the simplest form, if I give you a formula and I say give the empirical or write the empirical formula for the following, all you're going to do is simplify it. So this would be CH2. Ethane would change to CH. Glucose, we pull 6 out of each, so CH2O. And this one we could pull a 2 out of each, so C4H7. That's easy, right? Simplest form. Okay, well, it's not always that easy. So, all right, let's go backwards. Let's identify these as either empirical formulas, molecular formulas, or as both. Okay, so H2O, this would be a molecular formula. How do you know? Because it is water, and water is a covalent compound. Okay, C4H10. Okay, oh, and this would also be an empirical formula. Right? So it would be both. Why? Because it is the simplest form that you could possibly make. You can't simplify it anymore. All right, C4H10. This one is simply a molecular formula because it can always be simplified. CH, this could be both. Right? It could be both because it's the simplest and it's also a molecular formula. And then NaCl. It is an empirical formula. And it is a molecular formula, because it is the formula for the compound. Good? All right. If I don't give you the formula and I say calculate the empirical formula or find the empirical formula with these numbers, well, now you have to calculate it. So what is the empirical formula of a compound that is 25.9% nitrogen and 74.1% oxygen? All right, so let's write this down. 25.9% nitrogen and 74.1% oxygen. Okay, and we're looking for the empirical formula, which means the simplest form. All right, so steps that you're going to follow. If they give you percentage, you're going to change from percent to mass. Then you're going to go from mass to moles. And then you're going to divide by the smallest mole. And if it's not a whole number, if it ends up with like a decimal 0.5 or something like that, you're going to multiply by 2 to make it a whole number. Okay, so to go from percent to mass, or change this out of percentage, we're going to assume that it's 25.9% of 100%. So let's say that we had 100% of 100 grams. This would just be simply changed to 25.9 grams of nitrogen. And this one would be changed to 74.1 grams of oxygen. Making it easy, right? Step 1, done. All right, step 2, we need to go from mass to moles. And to go from mass to moles, remember we have to multiply by the molar mass. Yes, this all ties in together. All right, grams of nitrogen goes on bottom, moles of nitrogen goes on top. 1 mole is equal to the atomic mass, which would be 14.01 grams of nitrogen. Grams of nitrogen cancel. 25.9 divided by 14.01 gives us 1.8487, I'm going to round it, moles of nitrogen. Okay, same thing on this one. We put grams of oxygen on bottom because we want to get rid of those, and moles of oxygen on top. 1 mole of oxygen is equal to 16.00 grams of oxygen. And we do the math. Calculator gives us 4.63125 moles of oxygen. All right, step 2 done. Okay, step 3, it says divide by the smallest. So between these two, which one's smaller? Well, this one is smaller. So we're going to divide both of them by 1.8487 moles. Divide by 1.8487 moles. All right, when we divide something by itself, we get 1. When we divide 4.63125 divided by 1.8487, we get 2.5. Oh, that doesn't look like a whole number, does it? No, it doesn't. But guess what? We can multiply it by 2 in order to get a whole number. Now, what we do to one, we have to do to the other. So we multiply the whole thing by 2, which gives us 2 here and 5 here. Okay, now you're probably going, what in the world, Ms. Rourke, are we doing, and why are we doing this? Okay, guess what? All this math right here, we just did this to figure out our subscripts. Okay, so these numbers here are our subscripts. My S just went away. It's spooky. All right, subscripts. Subscripts for what? Well, this 2, go all the way back to the beginning, is for nitrogen, and this 5 is for oxygen. So our formula, our empirical formula for this is N2O5. And we're done. Okay. What if we wanted you to find the empirical and the molecular formulas? Well, to do the molecular formula, you just add a couple extra steps. It's okay. So, succinic acid is a substance produced by lichens. Chemical analysis indicates that it's composed of 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. They say it has a molar mass of 118.1 grams per mole. They want us to find the empirical and the molecular formulas. All right, so we've got 40.68% carbon, 5.08% hydrogen, and 54.24% oxygen. So the first thing we need to do is find the empirical formula. Find empirical formula. Okay, how do we do that? Well, we change from percent to grams. Remember, that's the hardest part. And guess what? I'm not even going to rewrite it. I'm just going to write over top of it. That's grams, and that's grams. That was the hardest part. Oh my gosh. All right, so after we change percent to gram, then we go from grams to moles. How do we go from grams to moles? We multiply by the molar mass. And we say grams of carbon on bottom, moles of carbon on top. 1 mole is equal to 12.01 grams. Grams cancel. And so 40.68 divided by 12.01. That is 3.39 moles of carbon. All right, we do the same thing for these. I'm going to fast forward, which means I'm going to pause and do it and then show you. Okay, next step is that was quick, wasn't it? All right, next step is divide by the smallest mole. So to divide by the smallest mole, and since 3.39 is the same for both, we divide by both, which gives us 1.48, which would round to 1.5, and 1. But we don't want that. We want a whole number, right? So we're going to multiply all of these by 2, which gives us 2, 3, and 2. So 2 carbons, 3 hydrogens, and 2 oxygens. So our empirical formula is C2H3O2. And then to find the molecular formula, you have to I'm going to write these down. Hold on. Okay, because I'm running out of time, these are the steps. So now first we have to calculate the molar mass of the empirical formula, which is 59.05 grams. Second thing we're going to do is divide the number in the problem by the calculated molar mass, which gives us 2. And then for step 3, we're going to multiply by the whole number, which gives us the molecular formula. All right, I know that went fast, but that's because I'm running out of time.